The problem I'm about to show you is the 7th challenge of the Advent of Code 2022. In the Advent of Code's subreddit, you can find many developers saying that they are stuck in this challenge, struggling to find a solution and asking for help. There are even some people saying that they spent over 10 hours trying to solve it. I wonder if the new ChatGPT can already do a better job and solve this problem in just a few seconds. Let's find out. The Advent of Code is a series of 25 challenges that takes place from 1st December to 25 December. Each challenge is split into 2 parts, and you only get to know the second part after you solve the first one. One interesting thing is that because when you are solving the first part you don't know the second part yet, so you have to make your solution flexible and generic enough to be useful to solve the second part as well. In the challenge, we are given a text file as input. Look at how it looks like. We have a list of basic Linux instructions that simulates a person navigating through some directories and listing the files and their sizes in them. The challenge is to find the sum of the sizes of all directories that are smaller than 100,000 bytes. As you can see in the title of the video, I'm going to show you how I solved the problem using ChatGPT. You can think that I only had to copy the challenge description and paste it in the ChatGPT text input, but that is not the case. The AI is not that sophisticated yet. We will have to break the problem down into smaller pieces and give the AI the information it needs to solve the problem. Here is what it outputs when I give the raw challenge description. It seems like a good approach. The AI gets the right idea, but there are some problems with the implementation. It does not parse well the ls commands, and it does not take into account, for example, that we can have multiple directories with the same name, but in different paths. But we only have a path of navigation, not the actual structure of the directories and files. So we have to first build the structure of the directories and files based on the information given by the simulated path of navigation given in the text input. I first thought about creating a dictionary or hash table that has as keys the name of the directories, and inside them we have all the files and folders directly inside them. This is what the final result would look like. After that, I asked the AI to give me the code to calculate the size of each one of the directories. It was possible to calculate the sum of the size of all files directly inside a directory, but we also have to take into account the size of the files inside the subdirectories of the current directory. So we have to recursively calculate the size of the subdirectories and add it to the size of the current directory. I asked the AI to do that for me, and even though it gave me some reasonable code and some insights and explanations about recursive functions, it was not working properly, because, as I mentioned before, we could have multiple directories with the same name but in different paths. And this was causing infinite loops errors with the recursive function. The AI wasn't able to notice that beforehand, but I asked it to give me a way to check if my folder structure had any infinite loops. It gave me a good solution idea, and it explained to me the reasoning behind it. But it wasn't working properly either, so I decided that my directory's structure was very problematic, and I had to change it if I wanted to solve the problem. This time, I asked GitHub Copilot to help me writing the code to build the directory's structure. This time the structure would look something like this, with the actual position of every directory in the tree, instead of every directory in the first level just being differentiated by their names. It gave me a pretty good solution, but again, it didn't take into account the fact that we could have a file and a directory with the same name inside the same directory. I had to make this change myself to make it work. After that, I asked the AI to give me the code to calculate the size of each one of the directories. I tried ChatGPT, but it didn't work as good as the Copilot. To get a good solution from the Copilot, I had to first break down the problem into 2 parts. First, I asked the Copilot to give me all the possible paths starting from the root directory. This will be useful to know all the directories existent in their tree structure. The prompt was something like this. Create a function that takes a hash table and return an array of arrays, with all the paths that lead to another object. Then I asked the copilot to give me the code to calculate the size of all the files inside a given directory. Given its path, this is the prompt I used. Create a function that takes a hash table and a path and returns the sum of all the files inside the path. The code it gave me was pretty good. I only had to make minor adjustments like getting rid of some duplicate paths that the first function was generating, and change the approach a little bit to account the directories that were inside a linear path of just directories, like this. Folder A contains only folder B that contains only folder C that contains some files. The copilot's solution wasn't getting it right, counting only one of these directories. Now that I have a function to calculate the size of a directory given its path, and a function to get the paths of all directories, I only have to iterate over all the paths and calculate the size of each one of them, and sum all the sizes that are smaller than 100,000 bytes to solve the problem, like this. I checked the solution in the Advent of Code website, and this time it was correct. In the second part of the challenge, we just have to find the smallest directory that we can delete to release the amount of space needed to run an update. The total disk space available is 7 million bytes, and the update needs 30 million bytes of free space. Now it is way simpler. We can ask the compiler to find the directories big enough to free the necessary space. And then we can just delete the smallest one of them, like this. And it gave us the correct answer again. With that, we finish our challenge. So, as you can see, it was possible to solve the problem using ChatGPT and GitHub Copilot. But the things aren't as simple as just copy-pasting the problem description and getting the right solution. The AI of these two tools is very competent, but it is not perfect. It can help you solve complex problems, but if you just give it a prompt for a complex system that the AI has never seen before, it will probably not be able to give you a good solution. But if you break down the problem into smaller pieces and give the AI more specific and detailed information about the problem you are trying to solve, it will probably be able to give you a good solution, and even explain to you how it works and why it works. In my opinion, these types of tools will continue to improve and become more and more useful in the future, but you don't have to be afraid of losing your job to them. Because, as you saw in the video, I had to do a lot of work to get AI to give me a good solution, and even then I had to make some adjustments myself, and this is just a simple problem that can be described in a few sentences. Imagine how much work you would have to do to get AI to solve a more complex problem, or design and implement a full system from scratch. It can still be very helpful in this kind of situation, but it really shines when there is someone who understands the nuances of the problem and can guide the AI. I hope you enjoyed this video. If you did, please leave a like and subscribe to the channel. I will be posting more videos like this one in the future. Thank you.